You can you can make a chart that shows what this code that kind of lays out the code. I guess maybe that's kind of how I showed you guys earlier. So when n equals 4, so it says the maximum number of electrons with these quantum numbers. So when n equals 4, that means there's a 4s possible. Okay, we'll just do boxes. So there's a 4s could be possible, a 4p. So 4p will have 3. A 4d is a possibility. So there's such a thing as a 4d. That's 5. And there's also a 4f possible. So that's 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Okay, so give the maximum number of electrons in an atom that can have these quantum numbers. So it could have, so an electron could be in any of these, so it could be spinning up or down in any of these boxes. So how many boxes are there? And then times that by 2, in other words. So there's 1, 3, 5, so that's 9, plus 7 more, 16, so times that by 2. So for A, it's 32. For B, it's when n equals 5 and the magnetic number is plus 1. So plus 1 would be, just assign this as plus 1, that one is a 0, or actually 1, 0, plus 1. And then assign this negative 2, negative 1, 0, plus 1, plus 2. This one's a negative 3, negative 2, negative 1. And the handout you guys have is like, like better looking pictures than these boxes. But whatever, these boxes will do. So when n equals 5, so you can have a 5, so a 5s is possible, but this is not possible for 5s because s is only assigned a 0 because it can only be one orbital. Okay, so plus 1, so it could spin up or down in the plus 1, so it could spin up or down. So 2 there. Okay, there could be 2 there, and then there could be 2 there, because you could have a 5s, a 5p, a 5d is possible, and a 5f. Okay, but this doesn't count because they gave us a plus 1 here. So the possible electrons 2, 4, and 6. So there's 6 on B. Where n equals 5 and this is a plus 1. So they're not discriminating like what orientation. So you could have a 5, you could have a 5s, a 5p, 5d, or 5f, and all they gave you was the spin. So that's a clockwise spin. So it could be, let's say these are 5s. So a clockwise spin in any 5. Okay, so it could be 1 there, there, there. Okay, it could be anywhere because they didn't specify that. So it could be in any one of these orbitals here, here. Okay, but only they did specify the spin, so it's only a clockwise spin. Okay, so it's the same number as there are orbitals, so that would be 16. Okay, where n is 3 and L is 2. So the L2 means a 3. So this is assigned to L of 0. This is assigned to L of 1, L of 2, and L of 3. So a 2 means 5. What am I doing here? So a 3D, we're on letter D. So, okay, so a 3D orbital. Okay, and that's all they specified. They just told you the sublevel. So what's the maximum number of electrons that can have a 3 and a 2 like that? It would be the maximum number. So they didn't specify spin either, so it's either clockwise or counterclockwise, and it could be any of these magnetic numbers. So 1, 2, 1, 2, here. Okay, so it should be 10. And then E, a 2 and a 1, so that would be a 2p. Okay, so any electron in the 2p, so that would be 6.